There are a couple different ways to do arrays and have more than one piece of type of information in it. One way is to do parallel arrays. Because in one case, we have an int. We want to store how old these people are, and we want to store their name. If we did a two-dimensional array, well, that's not going to quite work because the two-dimensional array has to have all the same data type. So if you look at it and think about it, a parallel arrays are just like a database. Here's one column, here's another column, right? It's just an in-memory database. In C++, we have to include the array library. So far, so good. And I have no idea. Oh, I know why I did this. There's a couple different ways to initialize an array in almost every language. This way, we're initializing the array with the elements that are in the array. So our size is going to be 2. Sometimes when I'm doing stuff, I'll put a constant for the array size just because a constant does not change. It makes the array very quick. But we're not making the array size from this. It's just I put in a constant for the size of the array. So far, so good. Next step. How do we go through each array in parallel? Each array is indexed the same way. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and on down the line. So if we loop through the array in our standard for loop with our little counter in there, it starts at 0. So then I can access the array saying X and X, and I can get both elements at once, parallel. So when I run through this, I'll get Tom 67, Harry 71. And I put in some, just strings so it looked nice. So far, so good. Okay, selection, in this case, I decided to use an int. Sometimes in menus, it's handy to have 1 and 2 and 3 and 4, especially in an array, because the 1, 2, 3, and 4 can line up very easily with the index of the array. However, my number here is 1. How do I make this line up with the array? Oh, I have a chat. Oh, Mike said hello. Mike says hello, everybody. Okay, so if I'm numbering this and I want a menu where I type in 1, how do I get the first element of the array? What would I do? It's indexed at 0. I'm typing in a 1. How would I get the 0 element if I'm typing in a 1? Excuse me?
I don't know your question.
Okay, so I have my menu. I want to be able to type in a 1.
Oh, can you just add 1?
You subtract 1.
Oh.
It's called the off by 1 error. So if I type in a 1, but I want the 0th element, I subtract 1 from it. Then I get 0 and 0 if I've typed in a 1. And this is true for almost any data structure like this. Every data structure in regular programming languages starts at 0, but users don't usually like to type in 0. They want to start at 1. So that's why it's called the off by 1 error. Arrays are common for that. So the other part of this is I have a while true loop, which is one way to handle a repeating structure. When it gets to here, if I type in a 0, I break out of the loop. And since there's nothing else going on in my program, I am out. If I put in a print statement here, let's see if I can remember how to do this. I haven't done a lot of C++ lately. And I say, bye. This is a quiz, by the way. And a colon, end L. Why do we have the end L in there? What does that do? So what does end line do? Your cursor is going along printing. Well, end line means that it's gonna put in a carriage return. It's gonna hit enter and go to the next line. So end line or /n gives you an enter key, and an enter key is an invisible thing. But that's what this does. If you want to have multiple print statements on the same line, you take out the end L. Now we have somebody else here. We have Pedro. Pedro is here. So the next question is, if I have this statement here and my while loop is here, right? There's my while loop. How often is this going to run? How often am I going to say bye? Because when I break, I exit the loop. When is this going to run? Every,
Just won't stand, just not in the loop.
is that what you're going to say, Ansonia?
Oh, sorry.
Yeah, it's outside of this. So that's something called scope. Scope is where things are alive, is one way to think of it. So for instance, if I'm in this loop and I'm doing something in here, this X, does this X survive outside the loop? Or is it only in the loop? What is its scope? This has to do with programming and secure programming. Where does this live? Does it only live here, or does it live and keep on going? So a best practice is to have your variables for only as long as you need them. If I do this and take this out of here and put int X, how long does that variable live? It lives how long? Well, it lives all throughout the loop. Once we exit the loop, it gets thrown away. So that's a little bigger scope. And we don't need that variable after this, right? We're done with it. We're not using it for anything else. We're just using it for a counter loop. So that's a best practice. Don't declare anything more at a higher scope than you have to, or a larger scope. As much as possible, you try to avoid doing global things. But would this program even work if we declared int selection in here? Sure. We could have declared int selection in here and it'll still work fine. I didn't even think about that. But we get the overhead of declaring it again and again and again. Is that better than being secure? Yeah. What do you think? Typically, you're going to declare arrays out here, so you don't have to recreate them every time around. Or if you want to change the value in the array, you don't want to have it redeclared and set to 0 again. In this case, the selection is only used once. And if it's redeclared, it doesn't matter. It's not a big deal to have it here or here. I just want you to be aware of what the scope is. So here, it's only part of the loop. Here, it's alive for the entire program. And if you declare it each time through the loop, you've got the overhead of creating this variable each time. Okay, so far so good? Okay, so we have scope going on. Now we have Sandhills Car Care. We have, how many arrays do we need in Sandhills Car Care?
2, one for the service, the other for the price.
Yep. Just like the last one. So how much of this program do you think is going to be very similar to what we just did? Is there any of this code we can reuse? Yeah, this is a good template. You could save it as and start making changes to it, and you'd end up with Sandhills Car Care pretty fast. Because we need array, we need IO stream, We need how big a size array we have. We need parallel arrays. Welcome to the program. We need a loop until somebody says bye-bye. We need a more extensive menu loop than this. You know, we're gonna have more ifs and stuff going on, but otherwise, this is almost virtually identical to the other one. So whenever you have a pattern like this, you can use that same pattern for the next program. You just have to expand your menu, you have different calculations, but it's the same idea. I basically gave you the pseudocode solution for the program. But since we're dealing with C++ and we're dealing with arrays, which are always a bit interesting, there's nothing wrong with me helping you out a little bit. Because arrays always, they cause consternation whenever you're dealing with arrays. Questions? Are we good with that explanation? Does that help you get through the Sandhills Car Care?
I think we did that in
We did.
Java.
We've probably done it in Python and Java, and now we're doing it here. So if you look back at your Java program, probably 90% of that code is going to be exactly the same, which is on purpose. Sometimes I do a program in multiple languages just to show the difference between them and how similar they are. And you can use that pattern again to create a new program. So you're converting from one type of syntax to another, which is useful. You know, if you're programming something in one language, but then you discover it should be in something else, well, you know how to switch it up. You've got the concepts of loops and decisions. You didn't memorize the syntax of a single language, which is better. Okay, let's stop that because I heard no